Today we will be doing 11.2 of 3D geometry. Whatever is required in this exercise I have explained in the previous videos. You can go and check the videos. Once you are done with the videos, then you can come to this and solve the problem together with me. Okay, sit along with your book. I'll be reading the questions and solution I have given in the video, so I will not be writing the questions, so make sure that book is with you. Now question number 1 says, show that the three lines with direction cosines, okay, direction cosines are given instead of direction ratios, okay, are mutual. The direction cosines of three lines are given and we have to show they are mutually perpendicular. Mutually perpendicular means they are perpendicular to each other. All the three lines are perpendicular to each other. That means this line is perpendicular to this line is perpendicular to this line is perpendicular to this line, so all are perpendicular to each other. Clear? Now look at this. Don't write this, just understand this. If I have two vectors a and b written as this, now if I say that those two are perpendicular, so you'll say the angle between them is 90 degree and cos of 90 degree is 0, so I have written it. Dot product, you remember, this is the dot product formula, and this side cos theta, so cos 90 is 0. Now if I substitute those vectors here, you can see a dot b, right? So from here a dot b, if I do, so I'll get a1 a2 plus b1 b2 plus c1 c2, and the denominator, these are the magnitudes of a and b, so I will be having square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. You can see clearly, right? So now you can see if this part goes on this side, this becomes 0. So if two vectors are perpendicular, you can say directly the product of the sum of their direction ratios are 0, or this you can say. See the previous. Okay, now what I do, look here, from here I split a1 with this, a2 with this. Okay, so see what I have written. Similarly I do with this second term, similarly I do with the third term, because this is the LCM for all of them. Okay, now you see here, if I do that, what are these? These are direction cosines. Direction ratio by the magnitude of the vector is the direction cosine, so I can write L1 L2 plus M1 N2 plus N1 N2 is 0. So whether they give direction ratios or direction cosines, to show mutually perpendicular, you just have to check the product of the sum. Okay, now see the direction cosine of first line is given like this, direction cosine of second line is given like this, direction cosine of third line is given like this. So see what I have done. For the first line, first two lines L1 and L2, have taken their direction cosines. You can see here, this is the direction cosine of line 1, this is the direction ratio of direction cosines of line 2. So you can see this into this, this into this, this into this. Okay, so you can see I have written here, and when you multiply them, you will get this. You should be clear with the calculations. Okay, don't be confused with the calculation. I know you know the calculation. So I proved that this is equal to 0, so I can say L1 is perpendicular to L2. So I hope you understand. So similarly you have to prove L2 perpendicular to L3, L1 perpendicular to L3. Now look at this. This is your L1, this is your L2, this is your L3. Now L1 perpendicular to L2, you have shown this perpendicular to this, right? L2 perpendicular to L3, shown this perpendicular, right? But you have not shown this one. So for that you have to show L1 perpendicular to L3. Understand? So if all are coming as 0, you can say they are mutually perpendicular. All are mutually perpendicular. If any one of them doesn't come 0, you will say all are not mutually perpendicular. Okay, only where you are getting this 0 after doing the calculation, those two will be perpendicular. Let's move to second question. Now question number 2 says, show that the line through the point 1 comma minus 1 comma 2 3 comma 4 comma minus 1 is perpendicular to the line joining the points 0 comma 3 comma 2 and 3 comma 5 comma 6. So you can clearly see that the one line is passing from these 2 points, okay, another line is passing from these 2 points. Now using these points, can I find the vector? Think in the previous videos you have done, right? Using these 2 points I can find a vector, right? And I need to show those two are perpendicular. But to show perpendicular, I don't exactly need the vectors, I just need their direction ratios or direction cosines. So what will I do? I will find the direction ratios of line 1 and I'll find the direction ratio of line 2 and I will check this condition. Then if this is satisfied, then I will say they are perpendicular. So I have written here, if L1 is perpendicular to L2, then this should be satisfied. Okay, this left hand side should be equals to 0. So see, so where I have written, I have denoted, because we are denoting our direction ratio from the beginning as a1 b1 c1 and direction cosines as l1 m1 and n1, right? So see, a1 b1 c1 are the direction ratios of line 1, a2 b2 are direction ratio, a2 b2 c2 are the direction ratios of line 2. So how do I find the direction ratio of L1? Now you see x2 minus x1, right? 3 minus 1, see I have written here, right? 4 from here minus 1, so 4 plus 1, clear? Then next one, minus 2 minus 2, so you can see I have written minus 4. So this is how I'll be finding my direction ratios. Okay, for line 1 2 points are given, so I can easily find the direction ratios, so I have written here. For line 2 similarly I'll be finding the direction ratios, so I got them. Now I'll calculate my a1 a2 b1 b2 plus c1 c2. Now from 1, where is our 1? You can see our 1 is, this is our 1. Okay, so I put the values now, so you can see a1 into a2, 2 3 is a 6, plus b1 into b2, 5 2 is a 10, plus c1 into c2, so there is a minus 16. So this becomes 0. I can say L1 is perpendicular to L2. Now let's move on to the next question. Now in the previous video we have already done the condition for perpendicular as well as parallel. If they are parallel, their direction ratios will be proportional. a1 by a2 is equals to b1 by b2 is equals to c1 by c2. Okay, so question number 3 says, show that the line joining through the points this is parallel to the point joining this. Okay, so look at the question, you will see the points there. So what you will do, you will find the direction ratio similarly like question number 2, and then you satisfy this condition. If this 3 you find out these 3 are equal, then you say they are parallel, otherwise they are not parallel. Okay, that should not be a big problem for you to be able to do. Okay, now question number 4. Question number 4 says that find the equation of a line which passes through the point and is parallel to the vector. Okay, this is based on equation of a line passing through one point and parallel to a given vector. So our equation was r equals to a plus lambda b, right? This was our, so we need to get this, we get from our point. This is the parallel vector. Now you see the point is given to me, so I got my a. The parallel vector is given to me, so I got my b. Now what I have to do, I just need to put it in the equation. Okay, so you should be very careful. The point which is given to you will give you a, and the parallel vector is this. Okay, so see, now question number 5. Question number 5 says, find the equation of the line in vector and in Cartesian form that passes through the point with position vector and in the direction of this. Okay, now they are saying it passes through the point with position vector. Now you look at the previous problem here. When I'm given a point and when I find this vector, what do you think this vector is? This vector is position vector of this point. Yes, because we measure it from the origin. 1 minus 0 I cap plus 2 minus 0 j cap plus 3 minus 0 k cap, right? Like that. So now position vector is already given to you in this question. So A is already given to you this. Okay, I have done directly because there is no point writing them again. So A already given to you, B is already given to you because it is in the direction. So in the direction, that means parallel to it. Okay, so B is this, so I have substituted, so I got the Cartesian vector form. Okay, now let's move on to the Cartesian form. Okay, our Cartesian form looks like this, right? So the problem here is x1, y1, z1 and a1, b1, c1. Now think, look at the question and think, which one will give you x1, y1, z1 and which one will give you a1, b1 and c1? The point will give you x1, y1 and z1. So what is your point? Point with position vector is 2 cap minus j cap plus 4k cap. So the points will be 2, minus 1 and 4. Agree? So I have written x1 as this, 2, y1 as minus 1 and z1 as 4. Now I get a1, b1, c1 direction ratios of the parallel vector. So what is our parallel vector? I cap plus 2j cap minus k cap. So our a1, b1, c1 will be 1, 2 and minus 1, right? So if you substitute them here, you will get the Cartesian equation, no problem. Okay, we already know how to write the Cartesian form, so directly we can substitute, we don't need to put. Okay, now question number 6. Read question number 6. Find the Cartesian equation of the line which passes through the point -2, 4, -5 and parallel to a line given by this. So already there is a line given to you. So suppose if I take the line as this is my line. Okay, so look at the equation of the line. This is our equation of the line. So according to that line, what is the point on the line? Look here, this is -3, 4 and -8, right? Those are the point on our given line, and these 3, 5 and 6 are what? Are the direction ratios of the parallel vector. So this is our parallel vector. Now we are given a point on the line. This is our required line, right? But one point is given on the line. Clear? Now if this line is parallel to this line, obviously this vector will also be parallel to this, right? So to get the equation of this, I can use this parallel line. Understand? So the point of making this diagram is to show you that if I need to find the equation of a line which is parallel to another line and whose all the things are given. So I can use this parallel vector for this one also. So this is my A, this is my B, right? So look here, the required line, the point from the line is taken already, x1 y1 z1, and direction ratios of the vector B, see, I have already taken. Okay, so if I want to write the Cartesian form, see, x minus x1, which was minus was already there, so x plus 2 by a1 is equals to y minus 4 divided by 5 equals to z plus 5 divided by 6. Okay, so it should be clear to you. Okay, the links are given in the description. If you don't understand anything, you go back and check. So this is a Cartesian equation, and the question is asking for Cartesian equation only. Let's go to question number 7. Now look at question number 7. Read, the Cartesian equation of a line is given as this. Write its vector form. Right, so look at the equation carefully. Can I write my A from there? Look at that. You can see x plus 3 by 3 equals to y minus 4 by 5 equals to z plus 8 by 6. So somewhere there A is hidden there, somewhere B is there, right? So, and we know the vector form of the equation is this, so I need A and B to write my equation, no doubt. So let's look at the question. I can find my point as 5i, look at the numerators, minus 4j plus 6k. I've already explained in previous questions. And B will be 3i cap plus 7j cap plus 2k cap, right? So A and B I already got. This is B vector, please change it, right? This is B vector. Okay, don't forget to write this is B vector. B vector is this. Okay, so this will give you the answer. Okay, let's proceed to question number 8. Question number 8 says, find the vector and Cartesian equation of the line that passes through the origin and the point. Okay, so it's saying origin and the point. So we have 2 points here. One is origin and another is the given point. So we can use that. But remember, r equals to a vector plus lambda times b vector minus a vector. That formula we can use. So A is got from one point and B is our another point, right? So see what I have written. Okay, so what I have written, I took these points as x1 y1 z1 and x2 y2 z2. Okay, so now my first A vector will be got from this point and B vector will be got from this point. Okay, don't confuse. Okay, so now see, A I have now we know our vector form is written like this. Okay, so A is 0 I cap plus 0 j cap plus 0 k cap. I have written here. Okay, and B minus A will be B vector I'll be getting from here and A vector will be from here. So what I have to do, 5 minus 0 I cap minus 2 minus 0 j cap 3 minus 0 k cap. So what I have done here. Okay, now when you simplify, this part will go away, lambda times this will be remaining. So that is the vector form. Okay, don't confuse. Now I need to convert this into Cartesian form. Now we have already seen that the Cartesian form is written as x minus x1 by x2 minus x1. Okay, so you can see here I can see here, so x1 y1 z1 directly written, x2 y2 z2 directly I have written. Okay, so you can substitute them here and then get the answer easily. Okay, don't confuse with x1 y1 z1, somewhere x1 y1 z1, somewhere a1 b1 c1. It's just notations. Okay, you need to understand notations. Accordingly you can write. Okay, here I have written x1 y1 z1 because this formula was there, Cartesian, so that's why, to make it clear, I wrote x1 y1 z1. Otherwise I would have written a1 b1 c1. Understand? Now I have shown you question number 8, okay, with 2 points. Similarly, exactly similar to that is question number 9. Find the vector and Cartesian equation of the line passing through the point 3 comma minus 2 comma minus 5 and 3 comma minus 2 and 6. Okay, so x1 y1 z1, you know what it is, x2 y2 z2, you know, just put in the formula, you will get the answer. Okay, so 9 you will be doing it yourself. Let's go to question number 10. Question number 10 says find the angle between the following pair of lines. So I'll be doing one, the other one you will be doing yourself. So question number 10 part 1. So if you are talking about angle between two lines, we use this formula, already we know, or we use this formula, right? So where b1 and b2 will be this, and you know what are b1 and b2, these are parallel vectors to the given line, right? So you see here, so from the first equation of the line you can see our b1 will be 3 cap plus 2 cap plus 6 cap, right? And the second equation of the line gives us b2 as I cap plus 2 cap plus 2 cap, right? And we know what are a1 b1 c1 a2 b2 c2, so we substitute them here. Okay, and then you see our cos theta will be this, and theta will be cos inverse 19 by 21. That is the angle. Okay, so if Cartesian equations are given, directly you can find your a1 b1 c1 a2 b2 c2. Okay, if vector form is there, first find your b1 b2 b1 vector b2 vector and then substitute them, you will get the answer. Clear? Not a problem. So question number 11. Now in question number 11 you can see a1 b1 c1 directly you can get from the equation. Question number 11 part 1. So a1 is 2, b1 is 5, c1 is minus 3, a2 is minus 1, b2 is 8 and c2 is 4. You can see the question, so we can directly use this formula and get the answer. I have not found the answer, you can find it yourself. Okay, that is for you. Let's move on to question number 12. Now this is interesting question. So the question says find the value of p so that these lines are at right angle. So if they are 90°, their angle, if they are right angle, the angle between them is 90°. So you can see L1 is given to us like this. Now our standard form of our line is always x minus x1 by a1 equals to y minus y1 by b1 equals to z minus z1 by c1. But here you see there is something else, right? So what I will do, I will bring x, y and z in front and I will make their coefficient as 1. So what I have done here, I have taken minus common so that x becomes positive and comes in front. Here I have taken 7 common. See, here nothing has to be changed. Okay, now I have taken 7 common. This I will take it to the denominator because I need my coefficient of y as 1. Okay, now you can see this minus also I have taken down, 7 taken down, everything. So I have modified them, I have transformed them into the standard form. Similarly for line 2, you can see I have to take minus 7 common. So see, taken x minus 1, Why I don't need to change it? It means that as it is. Here I need to take minus common so that z becomes positive and comes in front. So this 7 goes down, minus 7 goes down, this minus goes down, so ultimately I'll be getting this. Clear? Now if they are perpendicular, the product of their direction ratio should be, the sum of the product of their direction ratio should be equals to 0. So you can see if L1 is perpendicular to L2, A1 A2 plus B1 B2 plus C1 C2, this is a known equation. Now I have written, look at the previous lines and then write your A1 B1 C1 A2 B2 C2, and if they are perpendicular, their dot product should be equals to 0, right? And in the question they are saying that they are perpendicular. We need to find for which value of P. So you solve them, okay, then P comes as 70 by 11. That will be your answer. Now number 13, question number 13 says show that the line this and this are perpendicular to each other. So perpendicular to each other, what do you have to do to show perpendicular? You have to just prove this. A1 A2 plus B1 B2 plus C1 C2 is equals to 0. So write A1 A2 plus B1 B2 plus C1 C2, solve them. If it comes 0, then you say they are perpendicular. Now question number 14. Question number 14 says that find the shortest distance between the lines. So vector form of the lines are given to you. Now you know how to find the shortest distance. Shortest distance for non-parallel lines, D is equals to B1 cross B2 dot A2 minus A1 by magnitude of B1 cross B2, right? We know this for shortest distance between non-parallel lines. Okay, so you can do it. I have done examples in the previous videos, so you use that examples and then do it. Question number 15 also same. Yes, it is the Cartesian form, so from there you can get your B, you can B vector, you can get your A vector, A1 vector, B1 vector, A2 vector, B2 vector, you can get from there and then solve it. Question number 16. Question number 16 also exactly same. Okay, so you see that, see the previous videos, description is given in the link. So using them you solve these 14, 15 and 16, and in exam this kind of question comes, shortest distance question. Okay, and you know which formula to use when they are parallel and how to know if the given lines are parallel or not. Everything has been explained in the previous video. You go and check description, go and check the description, the links are given. Now let's move on to question number 17. Question number 17, just I want to show you that they are written in a different form, but you can bring them in actual a plus lambda b, a vector plus lambda b vector form. Okay, so see our line is given like this. You can see there is a t. Okay, so that t will act as a constant, which we had lambda before. Here we have t. In the second line you can see we have s as the constant here. So what I have to do, I have to separate t's together and non-t terms together. So what I did, I multiplied t in all of them. Okay, then non-t, those terms which are not having t, I combine them here, and those who are having t I have written here. Okay, our equation form is always like this, r equals to a vector plus lambda b vector form, right? So here there is a plus, you can clearly see that, so we will try to keep plus in our equation. So what I have done, I have taken plus t common from here. Okay, from here I have taken plus t common, I kept the minus inside, so you can see minus I plus j plus 2k, right? Or similarly here you can see I have multiplied I inside. Okay, and I have taken those terms which are not having s, I have taken together, and then I have written plus here. Okay, because of our standard general equation of the line. So I have written plus here, and I have taken s outside from this, and this. Okay, now you can see if I take s outside, then I'll be left with this. So this will be our b1, b2, this will be our a2, this will be our b1, this will be our a1. Okay, and using this you can use the formula and solve. So next we will be starting plane. Okay, and maximum marks is concentrated on planes. Okay, so you need to know lines nicely so that you can understand planes. Okay, dot product, unit vector, perpendicular condition. Okay, those things should be very clear and you'll be able to do it nicely. Okay, so I'll see you in next videos. Thank you.